Okay, so I'm going to show you how to graph a histogram. The data that we have is the density of two rods. And so we chose a histogram because the densities are quantitative data, meaning it is numbers, and also that we're going to be comparing density to density to density, meaning we're just making a comparison of the density values to see if there's any sort of patterns or trends. So, since I'm going to be doing that, the first thing I look at as to what to put on the x-axis. And so I'm going to write density and grams per centimeter cubed. So I got to change this into a cubed here. There we go. Okay, because that's going to be my label for the x-axis, and I'm going to put it all the way down there at the very bottom. Leave lots of space so I can write here. And then for my y-axis, I am going to have number of samples. Okay, that's a very generic. When you do a histogram, it's like number of samples, number of values, frequency sometimes is used. So I'm going to put that over there. Okay, it's just a very generic statement. So now I need to look at my densities and determine what the intervals are going to be for the histogram. So if I look at this here, the smallest number that I have is 2.4. And when I look throughout the whole thing, I find that the highest value I have is 8.3. So I need to make sure that my histogram actually encompasses those values. So I'm going to start at a low value and kind of work up. I need to make sure that I can fit it all in here. Each of these bar spaces here are going to be one interval. So an easy interval to kind of work with is to do things by like 0.1s or 0.2, 0.5, those sorts of things. So I'm going to try to go by 0.5. So I'm going to do 1.0 to 1.4. So that gives me 5 values in there. Okay. So when I look at the got 1.0, 1.1, 1.2, 1.3, 1.4, that's 5 of them. And then the next one is going to be 1.5 to 1.9. Okay. Now I have to kind of play with mine a little bit because of the sizing of the text. Yours will be a little bit easier because you guys will be writing with a pencil. But there you go. And then it's going to go 2.0 to 2.4 is the next interval, and 2.5 to 2.9 will be the next one, and so forth and so on. So I'm going to fill this out all the way. I want you to notice that the tens place goes 0505, and it'll do that all the way through. And on this side, the tens place goes 4949, and it will do that all the way through. So I'm going to pause mine for a minute while I fill this out, and I'll be right back. Okay, you can now see that I've filled out all of my intervals there. And so now I'm going to go up my y-axis. So each of these lines I'm just going to mark fairly simply with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way through. Okay, so I'm going to pause this while I go ahead and start labeling each of these with 0 and then 1 all the way up, and you can do the same. Okay, you can now see that I've labeled my y-axis with my numbers. So now what I need to do is go through and to actually graph my data. So when I look at my data over here, I see that we go from 2.4 was the lowest. So when I look at the intervals here, it's 2.0 to 2.4. So I need to make sure I get any number within there counted. So I look and I got 1, 2 numbers that fall into that area. So I'm going to go ahead and make a bar, and let's pick this. Okay, here we go. I'm going to go through, and I've got 2 of them. So there we go. So now that represents that I have 2 densities between 2.0 and 2.4. And now I'm going to count those that go between 2.5 and 2.9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. 10 of them. So I'm going to make a bar here that goes all the way up to 10. we go. And then I have only one of them that fall into the category of 3.0 to 3.4. So I'll just make a 1 there. All right. So now I'm going to look at the second column of data. And what I see here is the lowest number I have is 7.0. So that goes into the interval of 7.0 to 7.4. So I have 1, 2, 3 numbers that fall in that interval. So I'm going to take this up to 3. 1, 2, 3. And then for 7.5 to 7.9, I have 1, 2 numbers there. So I'm going to put a bar that goes 2. You notice these bars actually touch, unlike a bar graph. So that's because these numbers kind of flow right into each other. So we want to make sure we're indicating that or showing that by making sure they touch. Okay, so the last one I have is between 8.0 and 8.4, and I have 1, 2, 3, 4, 5, 6, 7, 8 of them. So I'm going to make this bar, starting here, to go up to 8, which is right there, and come across. All right, so now I've graphed all my data. And the last thing I need to do is to make a title. So the title is the density of 2 rods. Now you may be thinking, wait a minute, that doesn't match our typical title, because our typical titles are the effect of the IV on the DV. But because we are only comparing densities to densities to densities, we don't have an IV and DV. So that's why this gets that kind of title. Histograms get a very generic title. All right, the last thing that the graphing directions checklist always asks us to do is to kind of create a conclusion. So the conclusion that I can draw from looking at this data is that I have 2 trends. I have one here and I have one over here. And what these trends say is that the density of one of the rods is between 2.0 and 3.4 grams per centimeter cubed. And there is another set of rods that have a density between 7.0 and 8.4 grams per centimeter cubed. So from looking at this data, what I could conclude is that the 2 rods have 2 different densities, and so they are probably 2 different materials. And that is how you go through and you make a histogram, and that is how you draw conclusions from your histogram.